if you're watching a movie and someone is attempting to do fancy mathematics on a chalkboard, you'll almost always see a symbol that looks like this radical symbol. And this is used to the square root, and we'll see other types of roots as well. But your question is, well, what does this thing actually mean? And now that we know a little bit about exponents, we'll see that the square root symbol or the root symbol or the radical is not so hard to understand. So let's start with an example. So we know that 3 to the second power is what? 3 squared is what? Well, that's the same thing as 3 times 3. That's going to be equal to 9. But what if we went the other way around? What if we started with a 9 and we said, well, what times itself is equal to 9? And we already know that answer is 3, but how could we use a symbol that tells us that? So, well, as you can imagine, that symbol is going to be the radical here. So we could write the square root of 9. And when you look at this way, you say, okay, what squared is equal to 9? And you would say, well, this is going to be equal to 3. And I want you to really look at these two equations right over here, because this is the essence of the square root symbol. If you say the square root of 9, you're saying what times itself is equal to 9? And, well, that's going to be 3. And 3 squared is equal to 9. I can do that again. I can do that many times. I can write 4 squared is equal to 16. Well, what's the square root of 16 going to be? Well, it's going to be equal to 4. Let me do it again. And actually, let me start with the square root. What is the square root of 25 going to be? Well, this is the number that times itself is going to be equal to 25, or the number where if I were to square it, I get to 25. Well, what number is that? Well, that's going to be equal to 5. Why? Because we know that 5 squared is equal to 25. Now, I know that there's a nagging feeling that some of you might be having, because if I were to take negative 3 and square it, I would also get positive 9. And the same thing, if I were to take negative 4 and I were to square the whole thing, I would also get positive 16. Or negative 5, and if I were to square it, I would also get positive 25. So why couldn't this thing right over here, why can't this square root be positive 3 or negative 3? Well, depending on who you talk to, that's actually a reasonable thing to think about. But when you see a radical symbol like this, people usually call this the principal root. Principal square root. And another way to think about it, it's the positive. This is going to be the positive square root. If someone wants the negative square root of 9, they might say something like this. They might say the negative. Let me scroll up a little bit. They might say something like the negative square root of 9. Well, that's going to be equal to negative 3. And what's interesting about this is, well, if you square both sides of this equation, if you were to square both sides of this equation, what do you get? Well, anything negative squared becomes a positive. And then the square root of 9 squared, well, that's just going to be 9. And on the right-hand side, negative 3 squared, well, negative 3 times negative 3 is positive 9. So it all works out. 9 is equal to 9. And so this is an interesting thing. Actually, let me write this a little bit more algebraically now. If we were to write the principal root of 9 is equal to x. There's only one possible x here that satisfies it, because the standard convention, what most mathematicians have agreed to view this radical symbol as, is that this is the principal square root. This is the positive square root. So there's only one x here. There's only one x that would satisfy this, and that is x is equal to 3. Now, if I were to write x squared is equal to 9, now this is slightly different. X equals 3 definitely satisfies this. This could be x equals 3, but the other x that satisfies this is x could also be equal to negative 3, because negative 3 squared is also equal to 9. So these two statements are almost equivalent, Although when you're looking at this one, there's two x's that satisfy this one, while there's only one x that satisfies this one, because this is the positive square root. If people wanted to write something equivalent where you would have two x's that could satisfy it, you might see something like this. Plus or minus square root of 9 is equal to x, and now x could take on positive 3 or negative 3.